All right. It is Wednesday night. I am going to go through the circuit training for limits. Beginning with the first cell, you find the first one. You do the first problem, and then you look for the answer. You do the second problem, and it should lead you back. That last problem should lead you back to the infinity. Okay, so um, I hopefully have both screens up. Um, I'm looking at my phone right here, and then I have my camera right here. So let's get started. All right, so number one is asking for the function value at -1. So we're looking at this is your x value, and you're looking for your y value. So your y value is your solid dot. That would be a whole. So this one is -1. So -1 is going to lead us to this one. So we're going to mark that one as 2. And I just want to make sure that I'm doing these correctly. So we're going to go with that. All right. So the limit as x approaches 1. So what happens is you might hear my son in the background because he is loud and obnoxious. Hold on for 1 second. I'll go yell at him. Okay, here we go. Let's try this again. So on this one, when we always check the limits, we always want to check to see if we can do direct substitution. So direct substitution means that we're placing this number, the limit, into the function value. And if it becomes one of those indeterminate forms, then we are going to look for another way. So in this case, if we plug in 1, we're going to get 1 cubed minus 1 over 1 squared plus 1 minus 2, which is going to be 0 over 0. So this is that indeterminate form, which means we need to find a different way. Now, generally speaking, if we have rational functions, we're going to be factoring. That's one of the ways. We got to cancel something out because there probably will be a hole someplace. So this is the difference of cubes, and the difference of cubes is the cube root of this term and the cube root of this term, and then it's going to be the first value squared, the last value squared, and then in between we're going to multiply those together. And then we follow along with the rule of SOAP. And if you remember SOAP, it's the same, the opposite, and the always positive. So it's the same sign as this one. It's the opposite sign of the minus, and it's always positive. And basically what happens is we want to try and get something out. So generally speaking, that's probably going to cancel out. So how many times does 1 go into 2? -1 go into -2, and that would be 2 times. So we're going to put the plus 2 in there. That's kind of a simpler way to look at it when we're doing that. So now we cancel that out. That is going to give us our whole, but we're really not looking for our whole. That's the removable. So what we're going to do is we're going to now look at the limit as x approaches 1 of x squared plus x plus 1 over x plus 2. And when we direct substitution now, ds, direct substitution, we get 1 squared plus 1 over 1 plus 2, which is 3 over 3, which is equal to 1. All right, so let's find 1 someplace. I think that's on the second page, and that is in the bottom right corner. And in the bottom right corner, what they are asking you to do is to find this table. They don't want these values. Fill in the table what value would take place of e. They want this y value. So we're going to round to 3 places. So if I plug in 2.01 into this function, I know that the limit x minus 2 over, and I'm going to factor this because if I plug in 2, I get x minus 2 and x plus 2. I know the x minus 2's are going to cancel, and I'm going to be left with 1 over x plus 2. So if I looked at this, the limit of this is going to 1/4. I don't want the 1/4. I want the value that E would be. So what we're going to look at is we're going to plug in that case, the 2.01. So we're going to look at f of E, no, sorry, f of 2.01, which is going to be 1 over 2.01 plus 2, which is 1 over 4.01. And it says to use your calculator. So 1 over 1 divided by 4.01 is 0.249. 0.249. Reminder to make sure that you are they're round. They are cutting off, so they're not rounding. I think they are rounding on these papers. So this would be number 4. When you see this, if we use direct substitution, that'll be 0 over 0. We can't have that. So hold on for 1 second. All right, sorry about that. Little pause. I was away for about 2 minutes. All right. So in this case, what we have to do is if we direct substitute the 0 in, we get that indeterminate form. So what we're going to do is we are going to multiply the top and the bottom by the conjugate of the top. And reminder that we're trying to get rid of that. So what happens is when we FOIL this topic out, we're going to get x plus 3 minus 3, which is going to be x over x times the square root of x plus 3 plus the square root of 3. When we cancel this, we are left with a 1. So now what we're looking at is we're looking at the value of x approaches 0 of 1 over the square root of x plus 3 plus the square root of 3. And now plug in 0, I get 1 over the 0 plus 3, square root of 0 plus 3 plus square root of 3 is 1 over 2 square root of 3. And we get to put that into our calculator. 1 divided by 2 square root. Oops. I got to make sure I did this earlier. Make sure that that's in parentheses, because what it'll do is it will read it as 1 over 2 and then times it by the square root of 3. So this is 0.289. 0.289. So that 0.289 comes back over to this side, over to this page, and goes to this one. 0.289. So we have asking the question, is the function continuous at 1? If it's yes, go to the answer with 3. If not, go to the answer with 4. So what we're going to do is if it's continuous, then what that means is that not only is the limit approaching the same thing, but the slope is. We're not going to look at that. We're going to look at the values if they are going to be the same. So we're going to look at this because that is our restriction, and that restriction goes with this. So we're going to see if this top part is equal to this part when I plug in 1. So 2 times 1 minus 3 is going to give you 1 is equal to -1, and that is not equal. So if it's not continuous, we're going to go to -4. And -4 is right below it. All right, so wait a second. I've been messing up here. I haven't been numbering, sorry. All right, so that was 4. 4 goes to 5, and 5 goes to 6. And 6 goes to the limit as x approaches -1. So this looks like question 1. But now we're looking at the limit as x approaches -1. In this case, it is going, the left and the right are going to the same spot, and it is going to 0. So 0 is my next answer, and that is up here with number 7. All right, so number 7 we have this. We plug in 0, we're going to get a half minus a half over 0, and we get the indeterminate form. So what we got to do is, what I'm going to do with this, and there's several ways to do it. I'm going to find the common denominator of the top and the bottom, at least of the top. And the common denominator of the top is 2 times 2 plus x. So what I'm going to do is I am going to multiply this one by 2, and I'm going to multiply this one by x plus 2, or 2 plus x. I guess I should write it 2 plus x. And what that's going to do is it's going to be 2 minus 2 plus x. I'm going to clean that up just a little bit. So this x will attach to this, because if we divide by x, we're going to multiply by the reciprocal, which is going to be 1 over x. So it's going to attach to the bottom parts anyways. And 2 minus 2 plus x is going to be negative x over x times 2 plus x. And if you notice, these are going to cancel. And once those get canceled, you're going to have a negative 1. I'll write it in blue, keep writing it in blue. The negative 1 over 2 times 2 plus x. Oh, I need the limit as x approaches 0 now still, which is going to be negative 1 over, this will be, as that goes to 0, this goes to 4. So I'm looking for negative 1/4. Okay, so negative 1/4 yields us to this. They're looking for the vertical asymptote, and vertical asymptotes is when the denominator is equal to 0. So what happens is we are looking at the denominator is equal to 0, but in this case, if we're looking for 2 factors equal to, so we get 5 and 3, and we get plus and minus, we have to make sure, hold on for 1 second. Sorry about that. Okay, so this will give me my vertical asymptote, but if I'm looking at a limit, if I'm looking at this is also going to give me, one of these is going to factor out. So what we have to do is we have to make sure that we have no holes in these. So we're going to make sure if we're looking for holes. So I need factors of 6 whose sum is negative 5. So that would be negative 3 and negative 2. And if you notice that these two are going to cancel. So I'm looking kind of at x minus 2 and x plus 5. I want this not to equal 0. So x is equal to negative 5. All right, negative 5 is down here. And that removable discontinuity, that's the same question. So we canceled out, oh, sorry, the 1/4 comes from number 7. Sorry about that. 8, I gotta keep track of these. 9. So canceled out from number 8. Sorry about that. Where is that at? There we go. So we canceled out from number 8, we canceled out the x minus 3. And the x minus 3 is going to give us our whole at x equals 3. So if we have x equals 3, I need to do these in the morning when my son's not playing video games at night. Okay, so I'm looking at x equals 3. So number 10 is where x equals 3. Number 10 is x equals 3. That's this one. They want the limit as x approaches 1. So in this case, when x approaches 1, this is going to a spot, and this is going to 2, this one's going to infinity. So this one does not exist. Okay, let me just make sure I have my questions. Yep. So x equals 3 and x equals infinity does not exist. So in this case, we're going to go to this one, does not exist, goes to 11. And 11 goes, f of x has a hole. Oh, it has a hole. So that means that I removed something. So if I remove something, I need to make sure that it removes out of here. So I need 4 and 2. I need minus and minus. So I need to either take out a 4 or a 2. So what this factors out of, or into, or out of, is you can do this several ways. You can group. You can factor this by grouping. You can factor this by doing the quadratic and seeing which one has, or not quadratic, synthetic division. I did it with synthetic division because I checked 4 and I checked 2, and whichever one had the remainder of 0 came with it. So I think it was 4. And then I used the coefficients, drop it, and multiply, add, 0, add, positive 12. This gives me 0. Since that gives me 0, the x minus 4 is going to be the one that gets removed. So that is going to be x equals 4 is where the hole is. The other way, let me just do that quickly here for you. The other way is to do, sorry, I'm looking for a little note card here. The other way is to do this by grouping. And so we have x cubed minus 4x squared, and then plus 3x minus 12. So we're going to group with parentheses. We're going to take something out of this, which is the plus 3, and we're left with x minus 4. And if I group, I got to take out an x minus 4. So what did I take out of x cubed minus 4x squared to get x minus 4? And that would be an x squared. So there's my x minus 4 that will be the values that get canceled out. Okay. All right. So we're looking for 4 for number 12. Number 12 is 4. And that's that top one on that second page. So number 12, is it continuous at 0? Yes or no. So again, I'm checking to see whether cosine x is equal to x squared plus 1 at 0. So the cosine of 0, does that equal 0 squared plus 1? Cosine of 0 is 1, 1. This is yes. This is a negative 2. And negative 2 is down here. So we're looking at number 13. I might be rushing through these. I just wanted to try and get through these. They want the limit as delta x goes to 0. So as delta x goes to 0, I'm going to FOIL this. I'm going to multiply this through, and I'm going to subtract. So I'm going to get 4 times 4, which is 16, plus 4x plus 4x is 8x. That doesn't look like a 16. 8 delta x plus delta x squared, minus 12 minus 3 delta x minus 4, all over delta x. I'm going to cough here for a second. Okay. So I'm going to arrange this stuff and get this stuff cleared out, and get 5 delta x plus delta x squared over delta x, which means I get 5 plus delta x. And if I look at the limit as delta x approaches 0, this goes to 5. So 5 is going to be number 14. 5 is number 14, which is this graph on the second page. They want f of 1. F of 1 is that dot, which is 2. 2, sorry, goes back to here. So that was 14. This is 15. We're almost done. The limit as x approaches 1 from the left. So I suggest table, a graph, anything. We're not going to cancel anything. If I plug in 1, I get 1 over 0, which is undefined. So what I need to do is determine which way it goes. So you can do x divided by this x squared minus 1, excuse me. And if, oh, let me stop that for a second. Let's do zoom standard. And this is what it happens if x approaches 1 from the left. 1 from the left is this way, so it's going to go down to negative infinity. So I use the graph, and it goes to negative infinity, which is this one, which is 15, nope, 16. So 16 is my last one. What happens as x approaches 1 from the right? So what happens? It's going to positive infinity. Now the limit as x approaches 1 doesn't exist, because we got that from which graph? This one. So these two are basically the same, but that's saying that, so that goes to positive infinity, which leads us back to question 1, and the vicious cycle goes on. So I will post this. I hope my son screaming did not affect anything. If you can hear it, I'm just going to start doing my recordings in the morning when he's sleeping. I apologize for that. I will talk to you later. If there are any questions on this, shoot me an email, and we'll go from there. Thanks, everybody. Have a good night.